Good morning, students. Now some miscellaneous questions of second order derivative which are very important for examination point of view. Question number 1. If x is equal to a cos t plus t sin t and y is equal to a sin t minus t cos t, find d2y upon dx2, means second order derivative. Here the functions are in the form of parametric. So first we can take the functions. X is equal to a cos t plus t sin t and y is equal to a sin t minus t cos t. Now differentiating with respect to t, we get dx upon dt is equal to a d upon dt of cos t plus d upon dt of t sin t is equal to a and d upon dt of cos t, that is minus sin t, plus t d upon dt of sin t plus sin t d upon dt of t using product rule. So it becomes a into minus sin t plus t cos t plus sin t into 1. Cancel out sin t, you get at cos t. Similarly, y is given a sin t minus cos t. So differentiating it with respect to t, dy upon dt is equal to a d upon dt of sin t minus d upon dt of t cos t, that is equal to a d upon dt of sin t, that is cos t, minus t d upon dt of cos t plus cos t d upon dt of t using product rule in the function t cos t. So we get a cos t minus t bracket minus sin t minus cos t into 1, and after calculation we get at sin t, as cos t and minus cos t cancel out. Now dy upon dx will become dy upon dt upon dx upon dt. So putting the values, at cos sin t upon at cos t is equal to tan t, as at cancel out. Now we have the value dy upon dx is equal to tan t. Now again differentiating it with respect to x, so it becomes d2y upon dx2 is equal to d upon dx of tan t. Here it is a function of t and we are differentiating it with respect to x, so we will apply chain rule. Sec square t, tan, differentiation of tan sec square, and differentiation of t dt upon dx, but we have value dx upon dt, so we'll write sec square t upon dx upon dt. From above, dx upon dt has the value at cos t, so it becomes sec square t upon at cos t, and 1 upon cos t is again sec t, so it becomes sec qt upon at. This is the result. And there is a question number 2. If x cos a plus y is equal to cos y, then prove that dy upon dx is equal to cos square a plus y upon sin a. Also find d2y upon dx2. So we have x cos a plus y is equal to cos y. Differentiating with respect to x, here left hand side there are two functions, x and cos a plus y, so product rule will be applicable. X d upon dx of cos a plus y plus cos a plus y d upon dx of x is equal to d upon dx of cos y. So it becomes x and d upon dx of cos minus sin a plus y d upon dx into d upon dx of a plus y, applying chain rule, plus cos a plus y into d upon dx of x is 1 is equal to d upon dx cos y. So it becomes minus sin a plus y into d upon dx of a, that is 0, plus dy upon dx plus cos a plus y is equal to minus sin y into dy upon dx. So dy upon dx is equal to cos a plus y upon x sin a plus y minus sin y. After taking dy upon dx one side and other side, we get such solution is equal to cos a plus y divided, and put the value of sin a plus y x, that is the value of cos y upon cos a plus y, and here is into sin a plus y, which is not printed here, sin into sin a plus y minus sin y. Now this become cos, after taking LCM, it become cos square a plus y upon cos y into sin a plus y minus sin y into cos a plus y is equal to cos square a plus y upon sin a plus y minus y. This is the formula sin a minus b. So dy upon dx is equal to cos square a plus y upon sin a. Y cancel out. Thus we get dy upon dx is equal to cos square a plus y upon sin a. Now for again differentiating, we will cross multiply it. We get sin a dy upon dx is equal to cos square a plus y. So again differentiating it with respect to x, sin a is a constant quantity, so it will come out into d upon dx of dy upon dx is equal to, now d upon dx of cos square a plus y, first use power form, that is 2 cos a plus y power 2 minus 1. So this is 2 cos a plus y, and the differentiation of cos a plus y, that is sin a plus minus sin a plus y, and into differentiation of a plus y, a differentiation of a is 0 and differentiation of y dy upon dx. Thus it becomes using chain rule. So it becomes sin a d2y upon dx2 is equal to sin minus sin 2a plus y dy upon dx. This is the formula for sin 2 theta, 2 sin theta cos theta, and here in place of theta there is a plus y. So it becomes sin a d2y upon dx2 plus sin 2a plus y dy upon dx is equal to 0, or d2y upon dx2 is equal to minus sin 2a plus y upon sin a. This is the result. Here in dy upon dx there is a mistake. Above in cos a plus y divided cos y upon cos a plus y into sin a plus y. In numerator there is also sin a plus y. So correct it. Now you have some practice questions. Miscellaneous examples 44, 45, 46, 47 and 48. Read them and practice them. Okay, thank you.